Right, guys, we're on to one of my favourite parts of chemistry. We're going to be starting to talk about organic chemistry. So when we talk about organic chemistry, what we mean is anything to do with carbon. So to begin with, I'm going to go through this one word. Okay, this one word is called a hydrocarbon. And so when we do that, we're going to have a look at all of these things. Now, normally I get us to do this before the lesson. We sit there while you walk in and you go, what do all these things have in common? Why are they related? Because they all are related. And the first one over on the left over here, we have a crude oil distillery. Yeah, and that is where we dig up a bunch of hydrocarbons from the ground. Over here, we have bitumen. Yeah, or tarmac. That is also made of one of the products. Over here we have a airplane fuel. Okay, that's got related, and also good old plastic. Okay, now all four of these things have things in common, and that thing that they have in common is this stuff. Okay, they have hydrocarbons in them, and this is a really good definition to be asked a question on an exam. So it's a compound that contains hydrogen and carbon, but that's not enough. You must also say the word only. Okay, so let's go and have a look at our VCAR knowledge. So the VCAR knowledge says you need to know the origin of crude oil and its use as a source of hydrocarbons. Fine. And we need to group the hydrocarbons into families. And this is the fun bit. And if we get this down this year, then it makes next year a lot easier. And we need to know alkanes, alkenes, alkynes, alcohols, carboxylic acids, and non-branched esters. And then we're going to look at the way to draw them as well. So there's lots and lots of drawing, lots and lots of hands-on, really good topic to come back to school to. So these are some of the words that come up when you plug in all of your notes about carbon and organic chemistry. You know, the unfortunate thing about this word cloud is it's got carbon twice. So when we go to your notes, and we are on booklet number 8 at the moment, which is the carbon compounds booklet. And we're going to go right up the top and we're going to say, what is an organic compound? So carbon is found in 90% of all chemical compounds and is the basis for living organisms. That's why we call it organic. So as an organic compound is one which contains carbon, we call the study of carbon chemistry organic chemistry. Carbon is always linked with hydrogens. It's often linked with oxygen, nitrogen, sulfur, and chlorine as well. So some of the compounds that contain carbon and hydrogen: proteins, carbohydrates, funnily enough, that hydrate, and then 8. Now, if you remember back with our ionic compounds, an 8 means that it has oxygen. So carbohydrate has got carbon, hydrogen, and oxygen. Lipids, which are fats and oils, human body things, like lots and lots of other parts of our human body, which is usually made up of one of those macromolecules. Crude oil, wax, vitamins, aspirin, all of those. Okay. Carbon is present in so many compounds because it has a great ability for bonding. Now think about it, how many valence electrons does carbon have? If you've got carbon here, it's got 1, 2, 3, 4. So it's got 4 spots that it can join with other elements. So what we're looking at here is its electronic configuration. Yeah, if you can remember what electronic configuration is, we write it down here as being 1. Oh, it's not going to write for me. That's fun. 1. No, still not writing. I'm going to pause and fix this. 1s2, 2s2, 2p2. Okay, which means it has 4 valence, electrons. All of these electrons can participate in covalent bonding with other carbon atoms, hydrogen atoms, etc. And these bonds can be single. They can form double bonds. And they can also form triple bonds. So this is pretty cool. 1 triple, if I can spell. That one chemical can form all these different compounds. That's why it's so special. So the next little bit we talk about is the hydrocarbons. So hydrocarbons are organic compounds that contain only hydrogen and carbon. Now, these guys, having a look at them here, they are non-polar. So hydrocarbons are non-polar molecules that attract each other weakly by dispersion forces only. Hydrocarbons are non-polar because they are nice and symmetrical. Okay, there is little difference in the electronegativity between the hydrogen and carbon. So this bond here is very weak polar bond. And so what that means is the attraction or the dispersion forces increase in two things. Sorry. So there's two things that make the attraction or dispersion forces increase. The first one, when the molecules are closer, and that depends on their shape as to whether or not they can get closer, and also when they are larger. So the longer your hydrocarbon chain, the more surface area or electrons there are for attraction. So here, for example, is a nice long one. This is a molecule of gas, yeah, which has got 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms in the middle. And you can't see it because, of course, this isn't. Okay, so this molecule here is octane. Lots of things happening tonight. We've got non-polar because there's no net dipole, because there's all these tiny little dipoles within there, all these tiny little polar bonds, but they all cancel each other out. So let's look at the properties of hydrocarbons and then we're finished with them. So what do you think? Are they going to conduct electricity? Now, are they charged? Are they moving? No free moving charged particles. So we're not going to get electrical conductivity. What do you think about the melting point and boiling point depending on size? So a small one, its melting point and boiling point is going to be quite low, and a large one is going to have quite a high melting point or boiling point. And that's really important when it comes to the section on fractional distillation. Now, viscosity means thickness. So again, when you've got small chains, they're going to move past each other really easily. So those ones are going to become not very viscous, and the ones that are longer are going to be really viscous, really sticky. They're going to get tangled all up in each other. So that's why we say that it increases as size increases. Now, do we think these are going to be soluble? To be soluble, you need to be able to attract water. So if you can attract water and polar solvents, you need to be polar yourself. These guys, non-polar, so they only dissolve in a non-polar solvent. So they will dissolve in an oil, but they won't dissolve in water. And that is the end of hydrocarbons.